My name is Srilakshmi. The topic is output primitives in modern raster graphics systems. Here is an introduction to output primitives. Output primitives are the basic graphical elements used to create images in raster graphics systems. They serve as the fundamental building blocks for rendering scenes and images. Understanding output primitives is essential for grasping how modern graphic systems generate visual content. Definition of raster graphic systems. Raster graphic systems store images as a grid of pixels, each color with color and intensity information. These systems are widely used in digital displays, image editing, and rendering applications. Output primitives facilitate the creation, manipulation, and display of images within these systems. Types of output primitives. Common output primitives include points, lines, polygons, and curves. Each primitive serves a specific purpose in constructing complex images. The choice of primitives impacts rendering quality and computational efficiency. Points as output primitives. Points are the simplest primitives representing individual pixels or locations in an image. They are used for rendering small details or markers within a scene. Efficient points rendering is essential for high performance graphics applications. Lines in raster graphics. Lines connect two points and are fundamental for creating edges and outlines. Algorithms like Bressenhams are used for accurate line rasterization. Lines contribute to shape definition and scene structure. Polygon rendering. Polygons are multi-sided shapes formed by connecting multiple points with edges. Filling polygons involves determining interior pixels and coloring them appropriately. Techniques such as scanline algorithms optimize polygon filling. Curves and curves approximation. Curves are smooth, continuous lines like Bezier and B-splines used in graphics. They are approximated with line segments for rasterization purposes. Curves enable detailed and organic, organic shapes in modern graphic systems. Rasterization process overview. Rasterization converts vector primitives into pixel based images for display. It involves determining the which pixels correspond to the primitive shapes. Efficient rasterization is critical for real-time rendering applications. Filling techniques for polygons. Scanline filling traverses each row of pixels to fill the interior of polygons. Boundary line fill algorithms determine the edges of for filling. Proper filling techniques ensure accurate and visually appealing images. Anti-aliasing of op- output primitives. Anti-aliasing reduces visual artifacts like gagged edges on lines and curves. Techniques include super sampling and weighted average of pixel colors. Anti-aliasing improves image quality and visual smoothness. Clipping of output primitives. Clipping restricts in rendering to a designated viewport or window. Algorithms like Cohen, Sutherland, or Liang Barsky handle clipping efficiently. Clipping ensures only visible parts of primitives are rendered. Transportation of primitives. Transportation involves translating, scaling, and rotating primitives before rendering. Matrix operations are commonly used for applying transformations. Proper transformations maintain the spatial relationships within scenes. Shading and coloring of primitives. Shading adds depth and realism by stimulating light interaction with surfaces. In modern raster graphic systems, output primitives are the basic graphical elements used to create images on the screen. These primitives are processed in a logical way order to generate the final display. Point pixel is the most basic output primitive. A point represents a single location on the raster screen. All graphics are ultimately made up of pixels. Points are defined by their x and y coordinates. Line is the next important output primitive. The line is formed by connecting a sequence of pixels. Line drawing algorithms like DDA and Bresam are used. Lines are used to draw edges, borders, and outlines. Polyline is a collection of connected line segments. It is used to represent complex shapes and paths. Each segment shares an endpoint with the next. Circle and ellipse are curved output primitives. They are defined using center and radius parameters. Midpoint algorithms are commonly used to draw them. These primitives are used in wheels, buttons, and symbols. Polygon is one of the most important primitives. It is formed by joining multiple line segments. Polygons are used to represent 2D and 3D objects. Most graphic systems internally convert shapes into polygons. Fill areas are regions enclosed by boundaries. Scanline and flood fill algorithms are used. They help give solid appearance to objects. Text is also treated as an output primitive. Characters are stored as bitmap or vector fonts. Text is rendered using pixels on the raster display. Image bitmap is a collection of pixels arranged in rows and columns. Images can be photographs or scanned graphics. They are displayed by mapping pixel values to the screen. Attributes define the appearance of primitives. Color, thickness, style, and pattern are common attributes. The primitives are converted into pixels using rasterization. Rasterization maps geometric data to screen coordinates. The frame buffer stores pixel intensity values. The display controller reads data from the frame buffer. Pixels are refreshed continuously on the screen. The order of primitives ensures correct rendering. The simple primitives build complex graphics. Raster systems emphasize speed and efficiency. Modern GPUs accelerate primitive processing. Thus, output primitives form the foundation of raster graphics systems. Techniques include flash, flat shading, Pong shading. Coloring enhances the visual appeal on conveys. Role of APIs in handling primitives. APIs like OpenGL and DirectX provide functions for rendering primitives efficiently. They abstract complex rasterization processes for developers. These help API enable cross-platform and hardware accelerator graphics development. Challenging in rendering output primitives. Handling complex scenes with many primitives requires optimized algorithms. Balancing rendering quality and performance is a continuous challenge. Managing aliasing, clipping, and transformation simultaneously adds complexity. Advances in output primitive techniques. New algorithms improve rasterization, accuracy, and speed. Hybrid approaches combine rasterization with ray tracing for enhanced realism. Machine learning techniques are beginning to optimize primitive rendering processes. Future trends in raster graphics primitives. Real time ray tracing may reduce reliance on traditional primitives for realism. Increased integration of AI cloud automate primitive optimization. Hardware innovations will continue to enhance primitive processing capabilities. Output primitives are vital for constructing images in raster. Modern raster graphics systems. Advances in algorithms and hard hardware continue to improve rendering quality and efficiency. The thorough understanding of these primitives supports the development of sophisticated graphics applications. Thank you.